Sample problem 3.10 says that elemental analysis of lactic acid shows that this compound contains 40% mass carbon, 6.71 mass percent hydrogen, 53.3 mass percent oxygen. Determine the empirical formula and the molecular formula for lactic acid. So we can determine molecular formulas from empirical formulas if we have a molar mass, which a lot of times we can have by doing this mass analysis like they've done in this problem here, an experiment. So let's first of all, let's start writing down what we know. That's always our first step, right? I know I have 40% carbon. I know I have, 6.71% hydrogen and 53.3% oxygen. Now, remember, we need moles to determine the empirical formula. And the information they've given me here is all percentages. And so I'm going to give you a hint here. Anytime they give you mass percent, you want to assume that we have a 100-gram sample, because that means we have 40 grams of carbon, 6.71 grams of hydrogen, and 53.3 grams of oxygen, right? Those percentages just simply become the grams if you assume a 100-gram sample. So now we can figure out the empirical formula, because we all know, right, that we can convert grams to moles by using the molar mass from the periodic table. And so the molar mass of carbon tells me that it's 12.01 grams of carbon in 1 mole of carbon. The hydrogen, let's see, we have 6.71 grams of hydrogen. And the molar mass of hydrogen is 1.008 grams of hydrogen. There's 1 mole. So that equals. So let's do our math for both of those really quickly. I've got grams canceling grams, grams canceling grams. And I'm going to have 40 divided by 12.01. So I'm going to have 3.33 moles of carbon. 6.71 divided by 1.008. I've got 6.66 moles of hydrogen. And then we do the same thing for our oxygen. If I've got 53.3 grams of oxygen, the molar mass of oxygen is 16 grams in 1 mole. Directly from the periodic table, remember. Grams divided by grams cancels. I'm going to be left in moles. So I've got 53.3 divided by 16. And I got 3.33 moles of oxygen. And then we write our empirical formula, remember, or our formula, right, using the decimal numbers. So I've got C, 3.33, H, 6.660, 3.33. And I got to determine which one is the smallest number. Obviously, it's 3.33, right? That's smaller than 6.66. So for carbon, I'm going to have 3.33 divided by 3.33, because that's the smallest number, is equal to 1. For hydrogen, we're going to have 6.66 divided by the smallest number, which is 3.33. That's going to equal 2. And then for oxygen, we're going to have 3.33 moles of oxygen divided by the smallest number, which is 3.33, and that's going to equal 1. So our empirical formula is then going to be CH2O. All of those are whole numbers, so I don't have to multiply them by anything. And now I'm going to figure out what the molar mass of that is. That's the next step when determining the molecular mass, because that's what the problem is asking for, right? Determine the empirical formula and the molecular formula. So there's our empirical formula. The molar mass of the empirical would be 12.01 for the molar mass of carbon from the periodic table, plus 2 times the mass of hydrogen, because I got 2 hydrogens, so 1.008, plus 1 oxygen, which is 16 grams per mole from the periodic table. And I got 30.026 grams per mole. And now I'm going to figure out what the whole number multiple is that I need to multiply the empirical formula by to get the molecular formula. If you read in the notes or looked at the Learn Smart, you know that a molecular formula is just a whole number multiple of the empirical formula. So to do that, I take the molar masses. So I've got 90.08 grams per mole for the molar mass of lactic acid divided by the empirical formula mass, which is 30.026. We just figured that out. And what is that equal to? So I've got 90.08 divided by 30.026. That's equal to 3. So that means I'm going to say 3 times CH2O. And that's going to give me C3H6O3. And that's going to be the molecular formula for lactic acid.